Hello students, this is Smita Patnaik from Electronics and Telecommunication Department. So today we are going to discuss one more new topic, that is your radar, okay, and its types. Okay, let's start our class. Radar. So radar stands for here radio detection and ranging. Means it is an active transmission and reception method in the microwave in gigahertz range. So radar means nothing but a radio detection and ranging, which is used for gathering information of distant objects or targets by sending some electromagnetic waves. So these are the sensors which are used for contactless detection, tracking and positioning of one or more objects by means of electromagnetic waves to collect the information of different objects which are present far distance. So this is mainly used for distance objects. Next, let's see this diagram, okay, where this diagram indicates one radar antenna is there. Next, second here one target is present. So how we can collect the information about that distance target? Okay, here what happens, the radar system uses the same antenna, okay, from transmitting and receiving signals. This is done with the help of a what send and receiver switch. Okay, here we can use single antenna or we can use two antennas for receiving and transmitting purpose. But when one antenna is used for transmission and reception purpose, that is called your TR switch, means trans receive switch, or it is otherwise called as SR switch, means send and receive switch. So here what happens, let's see that antenna bandwidth is there. Next, here the radar antenna transmitted the electromagnetic waves, okay, transmitted pulses is there, okay. So if let us consider r is the distance of the object from the radar, and suppose small t is the elapsed time between the transmitter and the received signal, okay, then how we can find the radar range? Here r equals to ct divided by 2, okay. So here c is the speed of the light, so the formula is r equals to c into t divided by 2. Here the receiver requires a minimum amount of detectable power, okay, to separate the incoming signal from the noise. So this is known as your radar. So the maximum distance r beyond which the radar cannot detect the object, okay, that is known as your maximum range of radar. Next, working principle of radar, how it will work. Here the radar antenna emits a signal in the form of radar waves or in the form of electromagnetic waves, okay, so which move at the speed of light and are not perceptible by humans, okay. So these are the electromagnetic waves which are used to transmit, okay, when the wave hits the object, the signal changes and reflected back to the sensor. So similarly to an echo, one echo is also present when one obstacle, when the signal is reached at to the obstacle, then it will also return back. So next, the signal arriving at the antenna contains information about the distance object, and also it collect the information of different objects. So here what happens, the received signal is then processed in order to identify and position the object, okay. So in the second step what happens, it is possible to emit a pulse to trigger a reaction. It is mainly calculate its position, its velocity and its information about that distance object. By this way we can collect the total information of the distance objects. Okay, next here types of pulse radar. Okay, mainly the radar is classified into two types. First one is your pulse radar system. Okay, and second one is your continuous wave radar system. Okay, first we discuss about pulse radar system. Okay, here what happens, the radar which operates with pulse signal is called pulse radar. So here again the pulse radar system are classified into two types. First one is your basic pulse radar and second one is your moving target indicator, that is shortcutly called as your MTI system. Okay, next here what happens, the radar which operates with a pulse signal. Okay, for detecting the stationary target, here the target is stationary. Okay, means constant targets. We have to find what information about stationary targets. Okay, this principle is your basic pulse radar system, or generally it is called as your pulse radar system. It uses a single antenna for both transmitting and receiving purpose. So that's why it is also called as your TR switch or a SR switch with the help of a duplexer. Okay. So next what happens, antenna will transmit a pulse signal at every clock pulse. The duration between the two clock pulses should be chosen in such a way that the echo signal corresponding to the present clock pulses should be received before the next clock pulse. Okay, by sending this type of electromagnetic waves, we can calculate the information of different objects. Here the radio waves travels at the speed of light, so that it is easier to find out the objects. So next, this one is the block diagram of your pulse radar system. Mainly the pulse radar system consisting of three components. First one is your transmitter, second one is your receiver, and third one is your duplexer. And while connecting these all signals in the case of transmitter, then send it to the receiver through a antenna. So these are the basic components of your pulse radar system. Next come to your types of continuous wave radar. I am already explained you that radar is classified into two types. First one is your pulse, second one is your continuous wave radar. So next one is your continuous wave radar. Okay, this radar means which operates with continuous signal is called a continuous wave radar. Okay, they use Doppler effect for detecting non-stationary targets. In case of pulse radar, what happens? It is mainly used for stationary targets. But in case of continuous wave radar, it is used for non-stationary targets. In case of pulse radar, the pulse signal is transmitted, but in case of continuous wave radar, the continuous signal is transmitted. Okay, next, continuous wave radars can be classified into again two types, like your unmodulated continuous wave radar, and second one is your frequency modulated continuous wave radar. Okay, next, this one is the block diagram of your continuous wave radar. Here the main components of continuous wave radar are your transmitter, receiver, and one indicator also present, and last one is your moving target. Okay, here aircraft is your moving target. Here what happens, the energy reflected by a moving target gets shifted in frequency of suppose del F. Okay, a part of radiated energy reaches the radar receiving antenna directly here. Okay, so this wave has the frequency same as that of the transmitted wave. Okay, in the radar receiver, the direct wave of frequency combines with the wave reflected from the moving target. Okay, but the difference frequency is produced in the receiver output. Okay, so this one is the continuous wave radar. I hope you understand. Next come to some advantages of your radar. Okay, so first advantages is that an electromagnetic system used to detect. Mainly radar is used to detect the information about the different or distance objects. Okay. Next, it is also used for calculation of your moist, fogs and snow which are present in the space. Next come to, it can give an exact position of the object. Okay. And it can also determine the velocity of the target. Also, it is the difference between a stationary object and the moving targets. So, next, radar signal can target several objects simultaneously. Okay, so these are the some basic advantages of radar system. Next, come to your disadvantages of radar system. So, radar takes more time to locate, okay, an object. So, here what happens, large objects that are close to the transmitter can saturate the receiver. Okay, this one is the one more disadvantages of radar system. Next, it cannot differentiate the color of the object. Okay, next come to here, what happens, it cannot track if an object is declaring at more than 1 mph per second. Okay, so next, radar can be interfered with by several objects and medium in the air. Okay, while we are sending electromagnetic waves, it can interact with the different types of objects and different types of mediums. So these are the some, and it is also a low range and low power type of radar. Okay, it is typically a what? A complex method as compared to your other systems. So these are the some disadvantages of your radar system. Next come to your application. Okay, these radar systems are used in air traffic control system. Next, find out the navigation. Okay, air navigation. Next, remote sensing, marine and space, also used in military conditions. Okay, next, law enforcement and highway safety. So these are the some basic applications which are used in radar system. I hope you understand. Thank you.